Hello, everyone. Thank you for joining our webinar, Managing Infrastructure at Scale with Automation. My name is Carl Kalm. I'm a product manager here at Puppet, and today I want to walk you through a set of capabilities and challenges of customer challenges that we hear a lot from you all. Before I dive in, I want to take care of a couple of housekeeping items. If you have any questions throughout the webinar, please submit them by typing them into the chat on the left-hand side of your screen, and we'll answer as many as we have time for at the end. And also, if you experience any technical issues, please use the chat room to submit your questions and we can help you out. So let's talk a little bit about the current state of managing infrastructure at any meaningful scale. It really is a balancing act these days. You have to move fast to keep up with the business, but you got to keep the lights on. So you got to be able to deliver things really quickly, but still work with siloed teams with different priorities and different requirements. This really causes a lot of delays in business initiatives. So you see a lot of businesses slowing down because of the challenges of having to push teams to move fast when they aren't all perfectly aligned and they have different priorities and different requirements. And you really see this through the conflicting initiatives or incentives when you talk to these teams. Ops teams, they're all about stability. That's their job. Keep the systems running. Keep the things working. Dev teams, they need to deliver new features. They've got to get new customer value out in order to drive the business. Security teams, keep things secure. The business, they're all about delivering new value and pushing everyone in the company in order to be aligned across this value that they need to be able to deliver, while QA teams, of course, are ensuring that everything is going out meets customer standards. So all of that together means that you have teams that are not perfectly aligned to each other and they have conflicting priorities, and sometimes that results in high silo walls between them, where it's really hard to get all the teams to be able to operate together in a common goal and shared purpose. A lot of these multiple teams and business units own and operate different infrastructure, making this even more difficult. The inefficient processes and business initiatives that never happen because of these challenges or what holding your business back. And we really need to help teams be able to break down the silo between the ops teams and the specialist ops teams. A lot of times when I talk to customers, we see that it's not just application development and ops. Even within ops, there are specialized teams. There are teams that own infrastructure services that are at odds with, say, the team that owns the standard operating environments. And then that may be at odds with another part of the team that is trying to manage their own infrastructure in a completely different way. All of these different approaches and differences in coordinating change really slow down absolutely everything in that business. And it keeps the ops teams from moving from being viewed as a cost center into an innovation center. And we need to be able to help teams increase the number of task-based automations without having collisions. One of the challenges that we really talk a lot about is that if you have, say, self-service orchestration, you have all of these different automation tools being used and leveraged by different teams. How are you making sure that they're not conflicting with each other? How do you make sure that the InfoSec team, they manage the configurations in one way, but then the application team doesn't come right behind them and change it to what they need it to be, which is now out of compliance? How do you ensure that all of the standards are being applied to the infrastructure without actually colliding with each other? Because of all of these challenges, IT needs a holistic approach to managing infrastructure. You can't have siloed teams with siloed tooling. You can't have different ways of managing your infrastructure that aren't aware of each other. That slows things down, it reinforces silos, and it makes sure that you never know what the true state of your infrastructure ever is. That is why we built continuous delivery for Puppet Enterprise. We help you deliver changes faster with more reliability by helping tear down those silos, get visibility across multiple teams, but still make sure that those teams can move at the velocity that they need to so that they can keep up with the business and empower the core teams to be able to keep the lights on. With continuous delivery for Puppet Enterprise, you can scale your automation across multiple teams within your IT organization. You can use it to see the impact of a proposed code change and understand what the impact of that change is going to be. How many servers are going to be affected by this? How many teams are going to be affected by this? How many collisions, if any, will there be? Having that visibility helps you increase your velocity and increase your confidence that the change is going to do what it said it's going to do and not conflict with anything else. And it helps you scale your IT organization's ability to contribute to infrastructure configuration changes. I talk to customers all the time where they try and lock things down. In order to make sure that safety is maintained, the core Puppet team or core automation team or core services team, whatever it is for your organization, they lock things down and say, we will own how this content is written. We will own how the infrastructure is managed. And when you need something, you come to us and we provide it. That's obviously not going to work, though. That makes sure that one team is a bottleneck to the rest of the organization. That is not how you scale. With this tool, you can be able to scale out all of the different processes to each of the individual teams while still maintaining the safety on the middle by the core team, the core operations team. Together, that means that you can protect the infrastructure from unplanned and unwanted changes by analyzing the potential impact of that change and understanding what it's going to be before pushing and getting everyone involved in the change to approve it before it gets deployed. One of the things that I think is really important about this is also the ability to codify and measure the delivery pipeline to continuously improve code management deployments. Testing infrastructure is something that is absolutely critical, and being able to test infrastructure changes prior to a deployment to eliminate bottlenecks within the software delivery process is just as important for infrastructure as it is for applications. In fact, I'd say it's more so because the impact, the breadth of a single change can have on the business is far more than an application tends to be. So with that, I would like to jump into a demo where we're going to show a lot of these capabilities. All right. So this is continuous delivery for Puppet Enterprise. And what you're looking at right now is a Puppet module page. This is the pipeline that every single change for this module goes through on the right. And on the left in the middle here, you can see all of the events that have ever happened. And we can open these things up and understand what jobs were run. So RSpec Puppet, which is a unit testing framework. We can do a module PDK validate on every single command to make sure that the syntax in that change is correct. We can do an impact analysis like I talked about earlier. And so we can understand the history that this module has gone through. But I want to walk through a few of the key capabilities here. One is workspaces. So you can see here that I have my IT services workspace, where this is where we manage a lot of our core services and core standards of how the infrastructure is managed. But other teams, like the Windows team or the compliance team, we also have an RG Bank application-specific workspace for them, or the SAP team. This is where they go to manage their infrastructure that is completely independent of the infrastructure we're managing in the IT services workspace. I also want to talk through a little bit about deployments. And to do that, I'm going to show you a control repository. So this is our control repository. This holds all of our core modules and brings all of our roles and profiles and all of our hire data into one single location where we can coordinate that across different Puppet environments. But what I really want to show you is deployment. If you've ever done a deployment in Puppet Enterprise, you know all the steps that you have to go through in order to figure out how you're going to deliver the changes to the target nodes that the change is for. Well, with continuous delivery of Puppet Enterprise, we automate all of that away. First, you tell us which branch you want to deploy from. You tell us which server you want to deliver to with CD for PE, as we lovingly call it. You can deliver to multiple PE servers. So you can integrate as many PE servers as you have into this one workspace and deliver changes and coordinate changes across them. So here I'm going to deploy to my production environment. If you use prefixes, we ask you which one you would like to use. If you don't worry about it. Here's where the magic is, though. What we ask you next is, what policy do you want to use? If you select a direct deployment policy, that basically says, go deliver this change to all nodes in the infrastructure right now. That's great for things like development environments. Doesn't really work well for production environments because you probably don't want this change being pushed out to 20,000 servers all at once. That's what the eventual consistency policy is for. For really large infrastructures where you're fine if nodes just kind of check in every 30 minutes and on their regular schedule get the changes that they need, that's what eventual consistency policy is for. That just says, hey, go put the Puppet code into the Puppet server in the right environment and just leave it there. And the nodes will check in on their regular schedule and get the updates as needed. Then we have our temporary branch policy. This one's special. What this does is it goes through a process of creating a temporary temporary Puppet environment and starts peeling nodes off of the target environment, in this case production, into the temporary environment and running Puppet on them. And it does that in batches. So what we're doing here is we're saying, well, for batch size, we're going to do 10 at a time. It's probably a little small, so let's do 100. And we're going to wait 60 seconds in between each batch. Now, as this is going out, it's going to start peeling off 100 nodes at a time off of production, putting them into this temporary environment, applying the change. And when it's all done, it will go and update the production environment, destroy all the temporary node groups, Puppet environments, get branches. All of that gets cleaned up after it. And now your change has been rolled out over time in batches. And I also want to say something like, well, if we see more than 10 nodes fail, just stop the deployment. One of the beautiful things about the deployment policies is that we can define failure. So we understand if things aren't really looking right, and that means that you don't have to babysit your deployments. You just tell us what failure means for you, and then we will go and stop the deployment if things are not looking right. So I'm going to go ahead and do a deployment here. And here, what's going to happen is it's going to queue up this deployment. And then it's going to ask me for an approval because the production environment is what's called a protected environment. And so in the Puppet Enterprise server, we've said if any pipeline tries to deploy to production, it's going to need approval first. Every pre-production environment, hey, knock yourself out. Have at it. But when it gets to a mission critical environment, stop and wait for an approver to come in and approve this. Now, I just happen to be an approver on production, so I'm going to approve it. And now it's going to start going through all of the production deployment steps. So you can see here we've already created a brand new Git branch. We're deploying it out into the Puppet Enterprise server now. After that, we're going to start creating node groups. Then we're going to start running Puppet on those node groups into this temporary environment. And when it's all done, we'll clean up after ourselves. And instead of waiting for the paint to dry, let's go ahead and move on. What good is a deployment in this manual fashion if you can't add it to a pipeline? Well, you can. So what you can see here is we have these deployment stages in our pipeline where we are going to deploy, do these automated deployments to target environments, in this case, upper UAT, and in this case, down here into production. Now we have these auto promote in between these stages. And what this really means is that if all of these things succeed, go ahead and flow down to the next stage. And then in this case, go ahead and go all the way down into upper UAT and then wait for a manual promotion to production. So that way you can have these gates that make sure that a change is ready for you. When you're ready, hit the promote button and get it out. So that is our simplified deployments. Let's see if our deployment has moved along a little bit more, and it has. So we can see we've created our node group task. We've done our orchestration task here now. So this is actually telling all of these Puppet nodes, go run Puppet now and acquire this change. I can even break down and see exactly what job is being executed on the target Puppet environment. And I can see here actually that I have 4 failures. So if this hits 10, it's going to automatically stop, and I can dive in and understand what is going on. But for now, this has not met our criteria, so we're going to let this go. So now that we understand deployments, let's talk a little bit more about this Puppet module deployment. What this is doing is very similar. So with this, we have a pipeline where we're deploying out this module into the target environment, but we're doing that without having to go and coordinate a change on the control repository. We handle that for you. So now modules can move through a path to production without having to gate other changes that might be trying to go to that same environment because they have to require a git commit to the control repository. This is all automated for you now. And now you can decouple module pipelines from the path to production and control repositories. So teams can be able to define their own pipeline, manage their own pipeline, promote their own pipeline, and not have to block other teams or to be dependent on other teams in order to do that. Okay, so let's talk about how we actually go through and make a change. So we use GitLab internally, and let me make this a little bigger. What you can see is we have a new merge request on our RGBank application, so our RGBank module, excuse me. So let's dive in and take a look at what's going on here. Okay, well, we can see here that WordPress 1 has this issue where it's having trouble resolving different the IP for loading icons, and we can see that here. So yep, we've got these icons that are not loading here, and we have a proposed Puppet code change that will fix this. And it says, hey, instead of using our EC2 metadata public IPv4, we're going to use this FQDN fact for this parameter. I'm not really sure what this does. This isn't, something that I am an expert in on this infrastructure code, so I'm not really sure what's going to happen here. Luckily, CD for PE does. So if I look at the tests that have ran, I can go look at the pipeline that was triggered as a result of this merge request being put in. And we can see here that, okay, it's syntactically correct. All of the RSpec Puppet jobs ran successfully, so at least the tests all pass. But let's see what's going to happen to our infrastructure. And if I go into this impact analysis, I can see, okay, if I were to merge this change and deploy it into production, and deploy it to this CD PE delivery PE server, I'm going to have 5 configuration changes across 3 nodes. Let's dive into that. All right, now we can see all of the different configuration changes that are going to happen. I can also see the list of nodes that are going to be affected by this. This makes sense. So we have these 3 WordPress servers that are delivering this application, and this just makes sense to me. Like I don't see anything about any nodes that seem weird that shouldn't accept this change. So I think the scope of this is probably correct. But let's take a look a little bit further. I can see here there's this WordPress instance app. I want to dive into that a little bit more. Well, I can see here that there are 3 unique ways that this parameter is going to, or this resource rather, is going to change. The WP site URL parameter on it is going to change across 3 different unique ways. And I can see here why. It's because there's 3, it's going to change in 3 unique ways, each change for a unique server. And I can even dive in and see exactly what these servers are. So in WordPress 01, I can see that our current value is this, which is an IP address. That makes sense. And the new value is going to be using an FQDN. Okay, now I have a sense of what is actually going to happen should I go and deploy this change into production. And I think this is pretty safe. So I'm going to come in here. Oops, sorry. I'm going to go here. And then I'm going to go ahead and merge this change. Okay. Now we can see that new events have kicked off. We have oh, I'm sorry. I'm in the wrong place. I meant to be over here. Okay, we can see here that this pipeline has kicked off. We are executing this pipeline, but you can see that there's this deployment being queued up. And that's because if you look at our pipeline, we have something called a pull request gate. And what this does is it says stop the deployment if it's triggered by a pull request or a merge request in GitLab parlance. So earlier, when the merge request was put in, the only things that happened were these jobs were ran, the impact analysis was performed, and then when it got to this pull request gate, it stopped. But now it's been merged. So it's going to flow through the pull request gate down into the lower parts of the pipeline. In this case, it's going to go ahead and do a deployment into lower UAT. And now I can go through and validate that the change really does do exactly as it said it's going to do, and it really is going to work before I promote it into production. So this is a really powerful tool and a very powerful workflow. It means that all of your different teams that specialize in different parts of the infrastructure can be able to push changes through and be able to understand what the impact of those changes is going to be before they even go through the full testing and validation. That gives you a huge gut check right up front, where you can understand, should I even keep going with this? Is this, never mind pushing it out to a testing infrastructure if catalogs are going to fail, or if it's the wrong change, if configurations are going to change in the wrong way, or it's going to have too big of a breadth of change. It's going to affect too many servers. So it gives you that initial gut check to say, hey, is this even right? So that is the core capabilities of continuous delivery for Puppet Enterprise. I hope that was useful for you.